I'm going to quickly go over two problems that fourth period asked me to do today and make this available for second period since I missed you guys. But let's take a look at number 10 on your homework. Okay, it says a ship sails 12 kilometers from point A to point B at a bearing of 260 degrees. So if I put point A over here somewhere, here we go, and I need a bearing of 260 degrees. So if I think about that in terms of what a bearing means, 260 degrees would put me 10 degrees shy of 270. So this would be the bearing from A to B. So now I'm going to draw in that line from A to B. And there's my bearing, and that gives me my direction. So this is point B. And then it says at point B, the ship changes course to a 285 degree bearing. Okay, so if I think, okay, right here, we're going to change course and we're going to go 285. So 285 would put me 15 degrees past. And so that would shoot me off in this direction. Okay, and then this gives us C somewhere. Now we don't know exactly where it is. It could be up high, it could be down low, but let's just draw it there. All right, so here we have these two. Well, if this was 10 degrees shy right here, this would be 10 here because we have parallel lines cut by transversal. So if this is 10 degrees below this line, then above would be 80 degrees. And if this was 15 degrees here, then this would give us 75 here because that makes 90. So this large angle would be the sum of these two. So this angle would be 155 degrees. Now it tells us a distance here also. It says we went 12 kilometers from here to here, and then we went 18 kilometers from B to C. And it asks us to find the bearing from A to C, so from A to C, so with respect to A, and the distance from A to C. So we're looking at this distance here, and then we're looking at this bearing, and the bearing that we're looking for would take us from here all the way to there. Okay, so those are the things we have to deal with right now. Those are what we're looking for. Well, let's find this distance first. We can call this B because it's across from point B, or we could call that angle B if we wanted. So we've got the two sides and the included angle. Law of cosines would be a good choice. So we have B squared equals A squared plus C squared minus 2AC times the cosine of angle B. So in this case, B squared is equal to 18 squared plus 12 squared minus 2 times 18 times 12 times the cosine of 155 degrees. All right, and this will give us a B that is approximately, so we need to punch all this in and take the square root, 29.32 kilometers. So now we have solved for B, 29.32 kilometers. Okay, so now what we need though is to find our angle A. Because if we find angle A, then what we really need is this little part so we can add it to 270 so that we can find the bearing. Okay, so now we're going to find angle A. So how could we find angle A? There's a couple ways. One of those ways would be using law of sines. So we could say sine of A over 18 is equal to sine of 155 over 29.32. Okay? And if we solve for angle A, what we're going to find is that angle A here is approximately 15.04 degrees. So this entire angle, so if this little part is 10 and the entire thing is 15, if I take away that 10, that tells me it's 5.04 degrees north of west. So with a bearing, I would just add that to 270, and I would get that this bearing is 275.04 degrees. Okay, so that is one problem that we worked together today. Use law of sines, law of cosines, and we incorporated bearings. All right, now this one was from the worksheet the other day on area. So with area of a triangle, we can use the 1/2 AB sine of C to find our area, okay? But in this case, we have C and we have B, so we really need sine of A for this problem in particular. So we need to find this angle here. So to find angle A, what could we do? Well, we're going to have to work around to get to angle A. What we need to do is find angle B first using law of sine. So we have sine of 72 over 12 is equal to sine of B over 9.9. And then we would cross multiply and we would solve for angle B. And what you're going to find is that angle B is approximately 51.68 degrees. Okay, so if this is 51.68 degrees, then we can add that to 72 and subtract from 180 to get that angle A is 56.32 degrees. So that leaves 56.32 degrees for angle A. Okay, and now to find the area, we would say the area is equal to 1/2 B C sine of, I have to scooch over so I have enough room, 56.32 degrees. And then when we go to type that in to our calculator, we get approximately 49.4 square units. And that's one way we can apply area. All right, so now let's talk about today's lesson. And today's lesson uses some new type of directional orientation. And these are with respect to our cardinal points. So what you're going to notice is this first indicator is our cardinal direction. So with respect to east, we are going 24 degrees south of that. That's what this means. So with respect to east, so we're thinking off this eastern cardinal point, we're going 24 degrees south of east. And that's what that indicates. Okay, so this is a little new for us. So when we sketch this in here, so the footbridge built across the lake from a gazebo and a dock, from the tree 100 yards from the gazebo, the bearing is 24 degrees south of east. So we're going 24 degrees south of east to take us from the tree to the gazebo. So that would be 24 degrees here, south of east. Now, that would be equivalent to a bearing of 114 degrees. But this is with cardinal orientation. I want to show you, I did find the conventional bearing, we see 39.14, but you can also do this with respect to north. We can say it's 39.4 degrees east of north. Now look, when we come down here, we can say that this one is a bearing of 154 0.54, or we could also write this as 25.46 degrees east of south. So that first letter gives us which orientation we're using here, our cardinal point, south. With respect to south, this is 25.46 degrees east of that. Okay? All right, so let's go back to this problem now that we understand the notation and continue it. We know this is 100 yards. Okay, the second one, from the tree to the dock, is a bearing of 15 degrees east of south. So from the tree to the dock. All right, let's change it up here. Tree to the dock. All right, and what we have this time is east of south. So this is 15 degrees east of south. Okay? And the bearing from the gazebo to the dock, so now we can come over here, gazebo to the dock, is 33 degrees west of south. So we're going west of south this time to take us here, and that would give me 33 degrees. I didn't connect that perfectly, but okay. So that's how we get our information here. So what we can find first is this angle, because we can add these two up and subtract from 90. We can use the information we know about degrees and parallel lines. If this is 33, this is 33. If this is 15, then this would be 15. This gives us another degree measure. And pretty soon we have all the information we need to finish the problem. Probably the hardest part was understanding the notation here, and hopefully that example helped.